Assalamualaikum dan selamat sejahtera. We are from Group 7 who would like to present the types of civil engineering structure based on project instruction given. This is my team members. The first presenter is me, Nurul Nazura binti Jonet. The second presenter is Muhammad Faiz Bazli. The third presenter is Muhammad Alif Irwan. The fourth presenter is Muhammad Daniel Izwan. The fifth presenter is Muhammad Amirul. And the sixth presenter is Mazin Hassan. There are 6 types of civil engineering structure that we have been discussed, which is beam of house, truss, beam bridge, column, slab and car porch. My name is Nurul Nazura binti Jonet. My matrix number is DF200151. I would like to present the beam of the house. The beam is structural element that resists loads that are applied laterally to the axis of the beam. The structural type is known as fixed end beam, and the material of the beam is steel beam, and the beam is located at Pariani, Batu Pahat, Johor. Next is loading estimation. The loads that apply on the beam is 2000 kg. The weight of loads is 19.62 kN. Next, this is the free body diagram that consists of reaction at point A and reaction at point B. Next is support reaction. The reaction at point AX is equal to the reaction at point BX, which is 0. The reaction at point BY is equal to the reaction at point AY, which is 78.48 kN per meter. Then the moment at point A is equal to the moment at point B, which is 104.64 kN per meter. But there is different direction, which is the moment at point A is anti-clockwise and the moment at point B is clockwise. Next is centroid. First, we will find the area value, the x value, the y value, the ax value, and the ay value. Then we will proceed to the formula to find the centroid of the beam, which is the total of ax or the total of ay divided by the total of area. Next is moment of inertia. First, we will find the area value, ix value, dy value, and ady squared value. To substitute the value into the formula of ix plus a dy square to find the moment of inertia at x-axis. Then we will find the area value, iy value, xx value, and asx squared value to substitute into the formula of iy plus asx squared to find the moment of inertia at y-axis. Lastly is the conclusion. In engineering field, beam is a structure that commonly used in building construction. They typically transfer loads imposed along their length to their endpoints where the loads are transferred to walls, columns, foundations, and so on.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiz Bazli bin Arman. Today I want to present the structure of the truss. Truss is a structural framework design. Basically, trusses are triangular wooden structures designed to keep the integrity of a roof. The function of this truss is to provide a support and strength for a roof, and the material is timber. The location for this truss is at Kampung Teluk Malik, Jitra, Kedah. This is the free body diagram of truss, which is have 8 meter length and 6 meter high. Then the loading on structure. The mass of loading is 50.97 kg and the weight of loading is 500 Newton. Then support reaction. The support reaction at AX is equal to 0. Reaction for BY is 375 Newton and reaction at AY is 125 Newton. Then center of the centroid, X coordinate equal to 4 meter and Y coordinate equal to 2 meter. Then moment of inertia for X axis, Ixx equal to 48 meter power of 4 and Y axis Iyy equal to 63.8 meter power of 4. As a conclusion, a roof truss is considered the most important key component in engineering system in building. Without the roof, buildings will be exposed to all kinds of elements, rendering them completely useless. So, we need to use a good material for truss to give a strong support to protect a roof or building from collapse. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Muhammad Alif Irwan Berusnan. I'm going to explain about beam bridge. The location of the bridge is at Kampung Beletik and Kampung Kuala and Kampung Sungai Padi at Kuala Lipis, Pahang. The structural type is known as a simply supported beam. Next, For the loading estimation, I assume for the slab self-weight is 2,500 kg, and for the dead load, I assume 450 kg. For the total loading act on the beam, I got 28.93 kN per meter. Next, for the support reaction, for the total moment, I got 0 as the total moment. And for the reaction at RAY and RBY, I got the same, which is 700 to 23.25 kilonewton. Next, for the centroid XX is 25 meter, and the centroid of Y, we got 5 meter. Next, for the moment of inertia for horizontal axis, I got 4,166.67 meter power of 4, and for vertical axis, I got 104,166.67 meter power of 4. As conclusion, bridge is one of the most important structure that have the purpose to carry on the traffic load of the highway, crossing any obstacle, and perform an effective communication between two destinations. That's all from me. Thank you.
Assalamualaikum, my name is Muhammad Daniel Izzuan bin Ahmad Fairuz. My matrix number is DF200087. Now I'm gonna continue the presentation for the column. A column is a vertical structural member intended to transfer a compressive load. The type of material is being decided on the scale, cost, application of the construction. The location of this column is at Seremban 2, Seremban Negeri Sembilan. For the loading estimation, weight of load is 29.43 kilonewton. This is the free body diagram. And the support reaction at RAY is 147.15 kilonewton. For RAX is 0. Next, for the centroid, the coordinate for X bar is 0.5 meter, and for Y bar is 2.5 meter. Next, for the moment of inertia, for X axis, IXX is 10.42 exponent 6 meter 4, and for Y axis is IYY is 4.2 exponent 5 meter 4. And for the conclusion, a column is considered as the most important key in building construction. The column allows the load or the force from slab or roof to distribute to the foundation. That's all from me. Thank you.
Hi, my name is Muhammad Wirul bin Muhammad, and I'm going to explain about our next structure, which is slab. A slab is a structural element that used to support ceilings and floors. It is made out of concrete, and reinforcement bars are provided to enhance a good support. It is estimated that concrete slab lasts for about 30 to 100 years. It was built with a good grade of concrete and steel. Slab can be designed as one-way slab and two-way slab. Okay, this is our free body diagram for our slab. We have roller supports, beam supports. We use uniform distributed loads, and the span was 7 meter. So to determine either the slab is one-way or two-way slab, use the formula Ly divided by Ls, which is the longest span divided by the shortest span. So in this case, 7 divided by 3, we got 2.3. So bigger than 2. Hence, the slab we use is one-way slab. So the load estimation was 42.61 kN per meter. Okay, for next step, we calculate the support reaction for our slab. So we find the equation Fx and Fy. So for Fy equal to 0 is Ray plus Rby minus 42.61 times 7 is equal to 0. We can solve the equation first because there's two unknown, Ray and Rby. So I take moment A, then I get the value of Rby, which is 149.135 kN. Then I substitute it back to the first equation, and then I get the Ray value was 149.135 kN. Okay, now we are going to find the centroid for X and Y. So centroid X we get 1.5 meter, while centroid Y we get 3.5 meter. Okay, next we need to find the moment of inertia. So the first step we need to calculate the area, then we need to find the Ix. So for moment inertia at x, we use the formula b h power of 3 over 12, while for moment inertia in y, we use the formula b power of 3 times h divided by 12. So for moment inertia in x axis, we get 85.75, while in y axis we get 15.75 times 10 power of 6 meter. As a conclusion, SLAB influenced the whole structure of the buildings. All the materials and procedures involved along the construction need to be in the best manner to sustain load and last longer. So in this project, the SLAB calculated was one-way spanning, thus all the load distributed on the two main beams. So I think that's all from me. Thank you.
Assalamu alaikum, my name is Nazim Hassan Mahmoud. I'm a member of Group 7 for the course of Static and Dynamics. In this presentation, I would like to present to you our group project based on carporch. Introduction. A carporch is a covered structure used to offer limited protection to various vehicles from rain and high temperature of sunlight. Generally, it's made of concrete, timber, or steel. In this project, the example of carport was taken from Tamawiya, Kedah. Now we are going to see the free body diagram of the structure. In this free body diagram, you see the base is 4.5 distance in meter, where the height is 3 meter. The self-weight of the beam is 31 kN per meter. The dead load is 18.1 kN per meter, where the total load on the structure, which is exerted on the base from A to B, becomes 49.1 kN per meter. Then we are going to calculate the support reactions of the structure by saying that the summation of forces to the x direction is equal to 0, where the summation of forces to the y direction is equal to 0. After that, we're going to find the forces to the x and y direction. We finally see that the RAY is equal to 17.19 kN, where the summation of moment to the point of A is equal to 0. In a calculation, we found that the moment to the A direction is 165.7 kN per meter. Centroid of the structure. To find the centroid of the structure, we should find first the area, the x distance, the y distance, the ax, and the ay. The total area is 6.75 mm squared, where the ax is equal to 10.30 mm cubed, where the ay is equal to 6.75 meter cubed. Finally, the x hash is equal to 1.5 meter, where the y is equal to 1.0 meter, which is equal to 1 meter. The moment of inertia of the structure. First, we are going to find the moment of inertia of the structure about the x-axis. We're going to find first the area of the structure and the x area, the distance to the y direction, and then both multiply together. Finally, the moment about the x-axis becomes 3.38 times 10 to the power 6 meter power 4, where also in the same way the moment of inertia of the structure about the y-axis becomes 7.6 times 10 to the power 6 meter power 4. Conclusion. Based on conclusion above, it's found that the structure can sustain load until 180 kN. Hence, the engineers have to design this structure well depends on geological place and environmental conditions to avoid collapse. This is due to the less support from other structures. Carport, which is used to cantilever beam or fixed support, only depends on its self-weight and strength of material, besides the wall is hanging. Thank you, that's all for our project. Have a good day.